Alright guys, today we're going to do solving exponential equations. An exponential equation is one in which a variable occurs in the exponent. Okay, so we've been looking at these, we've been talking about these. An exponential equation where each side has the same base can be solved by using this property. If b to the x equals b to the y, then x equals y. If bases are the same, set the exponents equal to each other and solve. So normally that's pretty quick and easy. But the problem is some bases do not start off the same, so we have to rewrite the numbers with the same base. Example, how could you take 16 and write it with a base of 2? So we know that 2 times 2 is 4, times 2 is 8, times 2 is 16. So that would equal 2 to the 4th, which equals 16. So sometimes we may need to change the 16 to have a base of 2, okay, by using our properties of exponents. So here, the bases on this first one are the same. So when the bases are the same, the 7 and the 7, you take your exponents and you put them equal to each other. And then it's just a basic equation, and then we solve. So we're going to move our variables to one side and our numbers to the other. So we're going to subtract 1. We get 2x equals 3x minus 3. Subtract 3x. I get negative x equals negative 3. And then I'm going to divide by negative 1. And x equals positive 3. I can check this by plugging it in. 2 times 3 is 6 plus 1 is 7. So 7 to the 7th. 3 times 3 is 9 minus 2 is 7. So that would give me 7 to the 7 equals 7 to the 7. Okay, so here, this 3 and this 27 are not the same. But I can make the 27 have a base of 3. So I leave the first one alone. And I ask myself, 3 to what power gives me 27? Well, 3 squared is 9, but 3 cubed is 27. And then that's the x's outside of that. So then I have, bases are the same, so I can take my exponents, 2x minus 1, equals, if you remember, a power to a power, so that would be equal to 3x. Okay, so here I can subtract 2x. So I get negative 1 equals x. Again, I could plug that back in and check it with my calculator. Okay, so here we have 1/3 3x minus 8 equals 9 to the 2x. Well, I look, 3 and 9, I can get them the same basis. So first of all, if I have 1/3, I can change that from 3 to the negative 1. And then I have 3x minus 8 out here. And then I can change my 9 to 3 squared. And then a 2x out here. Now my bases are the same, so I can distribute that negative 1, and I get negative 3x plus 8 equals 2 times 2 is 4x. Okay, so I'm going to add 3x to both sides. Just a simple equation at this point. So I get 8 equals 7x. Divide by 7. So x equals 8 over 7. So that's what you do when the bases are the same, or you can do that and make them the same. If an exponential equation cannot be written with a common base, we need to use logarithms. Okay? So if you just have the log, and there's no base here, it has a base of 10. And remember we talked ln has a base of e. Okay, and if you did your delta math, you should know that also when we were condensing and expanding logarithms. To solve most exponential equations, you're going to isolate the exponential expression, take the log or ln of both sides. So how do you know which one? Are you dealing with regular numbers or e? And then solve for the variable. So let's look at a couple of examples here. Okay, so here we have e. So anytime you have a base of e, you're, instead of doing the log of both sides, you're going to do ln of both sides. So we're going to have ln e to the x equals ln 30. because remember, whatever you do to one side of the equation, you have to do to the other, and this doesn't change the equation. Okay, so then we're going to use the log properties. We know that this exponent can move to the front, so that will give me x ln e equals ln 30. Okay, so please remember that we are solving an equation, and we are solving for x. So this is x times ln e. So what is the opposite of times? Divide. So we're going to divide both sides by ln e. So that's going to cancel out, and x is going to equal. You can put that in your calculator, and you will get approximately 3.401. And we will tell you how to round these. I'm just going to kind of round to 3 decimal places and go from there. Now, if you don't know this, ln e is actually 1. So this is just ln of 30. Okay? But you can put this in your calculator, do ln 30 divided by ln e to the first power, because you have to put a 1 there because it always asks for the exponent, and you get that. Okay, so here, if you go back up to our steps, you want to isolate the exponential. So we want to get this by itself first. So we need to move this 2. So we're going to add 2 to both sides. We get 4x plus 2 equals 12 plus 2 is 14. Now, at first you would look at this and go, oh, I can get at the base the same, but 14 cannot be broken down with a base of 4 or a base of 2. So this tells me that I can't use where the bases are the same property. So I need to come up here and ask myself, am I dealing with numbers or e? Well, my base is a number, so I'm going to take the log of both sides. So I'm just logging both sides. And once I take the log of both sides, now I'm going to use my properties. This is an exponent, so it's going to come to the front. So I'm going to have x plus 2 times log of 4. So that whole exponent times log of 4 equals log of 14. Okay, so that's using that exponent property. Now, this whole thing is being multiplied by that, so I need to divide each side by log of 4. Okay, that's going to cancel and leave me x plus 2. And I'm just going to leave this right now because I'm going to put it all in my calculator at one time. Okay, so now do I have x by itself? No, I need to move this 2, so I'm going to subtract 2 from both sides. And I get x equals log of 14 divided by log of 4 minus 2. Okay, so if I hop over to my calculator, and I'm going to do the log of 14, close parentheses, divided by the log of 4, and you can hit enter here. And then we're going to subtract off the 2, and that's going to give me negative 0.96. So if we go back over here, log of 14, so x is approximately negative 0.096. Okay? So you want to wait until the end to do this, because if you round and then you round again, you actually don't have the correct answer. You have a more rounded answer. Okay, so here we have a whole lot going on. So first thing of all, we have to get this part here, the base raised to the exponent by itself. So that means I need to move this 6 and this 6. So I'm going to add 6 to both sides, and I get 6 to x to the x plus 3 equals 36. Okay, so we have that. Cut that off so something goes in. And then I need to move this. So this is being multiplied, so I'm going to divide. So I get 2x plus 3 equals 6. So then I'm going to ask myself, am I dealing with numbers or e? And I am dealing with numbers. So I'm going to log both sides. Log 2x plus 3 equals log 6. I'm going to move my exponent. So I hope you're seeing a pattern here. move the exponent, so I have x plus 3 times log of 2 equals log of 6. Then I need to, this is being multiplied, that's a 3 by the way. I need to divide by log of 2 on both sides. That cancels. And I have x plus 3 equals log 6 log 2. And then I'm going to subtract 3. So every time we take the log, divide by the log, and then move if there's anything else with the x. So x equals log of 6 over log of 2 minus 3. I go put that in my calculator. I have log of 6 divided by log of 2. Remember, these have the base of 10, so I can use this log button. And then I'm going to subtract 3, and I'm going to get negative 0.415. Okay, because all of these, so x equals approximately negative 0.415. Okay, so this is how you solve exponential equations. Check your plan book for your assignment. Reach out if you have questions.